Okay, gonna change a little bit of my lecture style right now. Now, don't worry, I'm still gonna give you everything that you need. But what I want you to do is what you see right now on the screen. I want you to, in just 1 second, I want you to pause the screen, and I just want you to copy all of this. And then after you've copied it all, mash play, and I'll get you to copy a little bit more, and then I'm going to go back and go over all of this so you can just watch me while I go over it. So pause the video at this point and copy down to right here, please. Okay, now take these next few problems right here, pause the video now, and copy this down. All right, now you should have this whole first page. So now let's go back, and you can kind of just sit back and look at your notes and listen to me while I go through this. First of all, remember what an exponent does. We've talked about this a little bit. Exponent tells you how many times to multiply the base times itself. So 5 to the third power is just simply 5 times 5 times 5, or 125. 2 to the fifth power is 2 times itself 5 times. Remember, if there's no exponent written, it's understood 1. Now, we did a couple of these earlier. Remember, when you raise a negative number to a power, like these two right here, these two, though they're read the same, they're not the same. If I read this, I say negative 5 squared. If I read this, I say negative 5 squared. But they're not the same. The difference in these two is this exponent is on the negative 5. In other words, it's on the outside the parentheses. So that means that everything that is in that parentheses is part of your base. Here, the 2 is outside only the 5. So in this problem, the 2 only applies to the 5, not the negative 5. And we discussed this when we discussed exponents in section 1.3. But this is just to remind you. So when you work these two, if it's written this way, negative 5 squared, you're squaring the negative and the 5. But if it's written without the parentheses, the square is only understood to be on the 5, not the negative. That's why it's only written once here and not twice like it is right here. Now, same way with this next one. This next one, negative 2 to the fourth and negative 2 to the fourth. In this problem right here, the 4 power is on just the 2. Not the negative. But in this one, the 4 power is on the negative and the 2. So the difference in those two is when you work it out, on this one right here, you put the negative once, but the 4 times is only with the 2. On this one right here, the 4 times is with the negative and the 2. And it affects your answer, because a negative times a negative times a negative times a negative, every 2 negatives gives you a positive. Same thing right here if you put it on x's. This is kind of where we're headed in a minute. This reads right here 2x to the fifth. This reads 2x to the fifth. They sound the same. The difference is in this one the 5 power only applies to the x. On this one the 5 power is outside of a parentheses. That means that that 5 power applies to everything in that parentheses. So if you write out the top one, here's what it would look like. 2 to the first, and then it would be x times x times x times x times x. Now, we're not going to write it out that way, and it's okay that you've written it. But I just wanted you to understand that 5 power only applies to that x. But in the bottom one, if you write it out the long way, it's 2x times 2x times 2x 5 times. So now all of this is part of your base. Okay, so that's just a little bit of a review over, now part of that, the X stuff there, I didn't mention that earlier in the course, but the other stuff I did. So What I want to do now is I want to go over some exponent rules with you. And what I will do is I will give you the rule, I will have you to write down the definition, then we will do the examples. So let's start out with our first rule in dealing with exponents. And this rule is called the zero exponent rule. The zero exponent rule. Now, what I want you to do for right now is I just want you to accept this at face value. I will show you in a few minutes where this comes from. So right now, just like if I say, what is pi equal to? Most of you know that it's 3.14, but you don't really know where it comes from. So all I'm wanting you to do is just accept it for the time being. All right, here's what the zero exponent rule states. So write this down. Any base raised to the zero power equals 1. Any base raised to the zero power equals 1. So in other words, this. A to the zero power is 1. Now let me mention this first. If I want to raise, or if I want you to raise anything to the zero power has to be written. Because if the zero power is not written, it's understood 1. So if I want you to do a zero exponent, it has to be put for you. All right, so anything to the zero power is 1. But this is where you have to be careful with this. Tied in with what we did just a while ago in all of those examples. Let me show you what I mean. All right, so here's what I'm going to do. I'm going to do what I did a while ago. I'm going to put all the examples up. And I will tell you, okay, stop and copy it. And then once you get it copied, then I'll go back over it. That way you can watch me go through it. Okay, so make sure you've got all the videos in your... Okay, pause the video now and copy these. Okay, you should have these copied. Now, let's go over these together. All right, so now let's pretend like you're not looking at the answer there. So, anything to the zero power is 1, right? So, 5 to the zero power is 1. Got it. 3 to the zero power is 1. Got it. 2/3 to the zero power is 1. Got it. X to the zero power is 1. Got it. -5 to the zero power is 1. Got it. Now you say, okay, that's enough examples. This is the next one is where you have to be careful now. When I say anything raised to the zero power, any base raised to the zero power, you have to make sure you understand what I mean by base. See, in this problem right here, the power is 0. Your base is everything. And this one right here, your zero power is just above the 5. So this zero power applies to the 5, not the -5. So the base here is not -5, it's just 5. So you apply the zero power to that, but not to that. So when you work that, that's why that answer is -1. As a matter of fact, this right here, you don't have to write this down. This -5 to the zero power is really the same as -1 times 5 to the 0. That's basically what that is. Okay, so 2x to the 0. The zero power applies only to the x, not the 2. The 2 has its own exponent. So it's not in parentheses. So x to the 0 is 1. And then 1 times that 2 in front just gives you 2. Same thing here. -7 to the m to the 0. That zero power applies just to the m, not the -7. So it's going to be -7 times 1, which is -7. But if you put it in parentheses, the zero power applies to all of it, therefore giving you the answer of 1. Now, on this last one, you're adding two things together. So we've got to do this part first and then this part. Okay, 0 power is not on the 7x, it's just on the x. So we do x to the 0 power, which is 1, and then 1 times 7 is 7. So this is 7. Over here, the 0 power applies to all of it, which makes that 1. So this is going to be 7 plus 1, which of course gives you 8. And that's where that answer there comes from. Now again, I told you I would explain in a few minutes why anything raised to the 0 power is 1. Just not ready to do that yet. Okay, now let's look at rule number 2. Rule number 2 is called the product rule for exponents. The product rule for exponents. Okay, first in mathematics, what does the word product mean? In mathematics, the word product means multiply. So we're talking about multiplying two terms with exponents. I'm not talking about multiplying 5 times 3, which is 15. I'm talking about multiplying two variable terms that have powers on them. How do we do that? All right, take this note down, pause it at any time so that, so you can get the note down. Here's the note. If we are multiplying two terms having exponents, now let me stop right there. Of course, they all have exponents. It's just understood ones that they do. So if we're multiplying two terms having exponents, their bases must be the same. Underline that word must. Their bases must be the same. Continue the note. To do this, we will keep the base and add their exponents. Now, let me show you basically an abbreviation of what I just said. Write this down right here. Pause the video and write that down. Now, let me show you that this is an abbreviated form of everything that you just wrote. Watch. If we're multiplying two terms that have exponents, what has to happen? Their what? Their bases must be the same. If they're not, you can't multiply them. Their bases must be the same. And then it says, if they are, we will keep the base and add the two exponents together. All right, so what I want to do first is I want to show you one where I say, let's just use the rule, and then I'll explain why this rule works. Okay. So, let's write this problem right here down. X to the third times x to the fourth. Are we multiplying? Yes. Are the bases the same? Yes. Then what do? Keep the base, yes, and add the exponents. So according to that, then the answer should be x to the 7th. Now, one of the things that I commonly have students ask is they'll say, Mr. Rayner, why isn't that x to the 12th? It doesn't make sense. And they'll say, well, x to the 7th doesn't make sense. No, x to the 12th doesn't. Let me explain why. You don't have to write this out. I just want to show you where it comes from. If we write out x to the third, isn't it x times x times x? And then if we write out x to the fourth, isn't it x times x times x times x? So, if you have that, then you're multiplying x times itself how many times? Starting here, all the way across, 7 times. So there's not 12 there. That's why x to the 12th doesn't make sense here. Okay, So what I'm about to do is I'm about to put up some problems, and I just want you to copy them, and then I'll go over them. Okay. So, pause the video and copy these. Okay, you should have these down. Now let's see where these come from. M to the 4th times M to the 9th. Add. Y to the 4th times Y to the understood 1. X to the 7 times X to the 0. X to the 7th. Let me show you something else. You say, well, Ms. Brown, I thought you said X to the 0 power is 1. Okay, put a 1 here. 1 times anything is just that. So, or you can just say add the exponents. Okay? M to the 8th, M to the 8th, M 16. X to the 1st times X to the 1st, X to the 2nd. P to the 8th times P to the 10 is P to the 18th. Okay, now let me talk about something else that I talked to you about a little bit earlier in the semester. And it's this. It's the commutative property. You don't have to write this down. The commutative property, remember, just simply means if it has a commutative property, it means you can switch the order and still get the same answer. So is 5 times 7 the same as 7 times 5? Yes. So multiplication has the commutative property. 5 plus 7, same as 7 plus 5? Yes, it is. So that has a commutative property about it. But it's 10 minus, addition does. But is 10 minus 3 and 3 minus 10 the same? No. Subtraction does not have the commutative property. Now, look at this. If I multiply 2 times 3 times 4 times 5 times 6, since multiplication has the commutative property, that is the same thing as if you multiply 4 times 5 times 2 times 6 times 3. Same answer, as long as you have all those numbers there. Now, look at this next one. You don't have to write this down. So if I have 4 times x times y times 3 times x times y times x, this is all multiplication. So this means then that I can swap the order. So if I swap the order and put 3 times 4 first because they're numbers, then I put all of the x's, 4 of them, and then all of the y's last. That is the same as that, since it's all multiplication. But by putting them in this order, I can do these two together. That's 12. I can do the x times x times x times x. That's x to the 4th. And I can do the y times the y times the y. That's y to the 3rd. So when I multiply those together, I get 12 times x to the 4th times y to the 3rd. Now, you don't have to put that dot in between them. It's understood. Now, I would put the dots in between the two numbers, because if you don't, it'll look like 34. So anyway, that's the answer to that problem. Okay, now, let's look at this problem. So do write this one down right here. Okay, now, I don't want you to write it out this way. I just want you to watch. If I was to ask you, how many things are we multiplying together, you would probably be tempted to say, we're multiplying this times this. So we're really multiplying two things together. That's really not true. This is really, if you read it, this is really 3 times x squared times y cubed times 2 times x to the 5th times y. So it's really 6 things there multiplied together. Don't write this down, just watch. So that's really what it is. Now, multiplication is commutative. So we can swap the order. Now, this is what I want you to do. Since this is all multiplication, you can just multiply the numbers together, these two together because they have the same base, and these two together because they have the same base. Since it's all multiplication, there's no adding and subtracting here. So when you do that, this would be 6, x 7, not 10, y4. Okay, so let's do one more here. See if we can go straight to the answer here. Negative 7p5 x9y times 4p9 x0. All multiplying all the way across. No adding and subtracting. The reason I'm harping on that is later on there will be some adding and subtracting in here. No exponents out here. So this is all multiplying. So just simply multiply these two numbers together. That's negative 28. P5, P9 would be P14. X9, X0 adding would be X9. And then you'd have a Y. So the answer to this is simply that. And no, it does not matter what order you write these in. If you write X9, P14Y, or put the Y first, it doesn't matter. That's the answer to that problem. So that's rules of exponents. We've done two rules, the zero exponent rule and now the product rule. Next video, still in section 5.1, part 2 video, will be our third exponent rule.